Hi, everyone. Welcome. My name is Amitai. We're going to start in about 60 seconds. So we'll just let some people join, and we'll get started, as I said, in about 60 seconds. Thank you for joining today. My name is Amitai Richmond from K2View, and we'll get started momentarily. Okay. Good morning to our viewers in North America. Good afternoon to participants in Europe. Hello to everyone around the world. Welcome to this K2View virtual session on test data management. My name is Amitai Richmond, and I'll be your host today. If you have any questions throughout this presentation, please submit them, and I'll try to answer them at the end of the session. If I don't get to it at the end, I or one of my colleagues will follow up with you afterwards. So today we're going to talk about the new DevOps world. We're going to talk about where test data fits into this DevOps world and the challenges inherent in test data. And we'll talk about shift-left testing. We're going to talk about DevOps TDM best practices. We'll look at Gartner research on the subject. We'll talk about strategies and what some of our customers are doing today in the world of test data management. Then we're going to talk about 5 different approaches to test data management, followed by Q&A. So we live in a DevOps world. DevOps methodologies are widely adopted, no doubt about it. It's evolved a lot through the years since those early Toyota days, through Kaizen and Lean, and now agile software development. All have played a role in the development of DevOps over the last few decades. So change and disruption is here. It's here to stay. And the only way to survive, to thrive, and compete is to continuously evolve, to deliver software and products faster, to increase speed and flexibility, to make more code commits every day, to increase the software quality, making sure to get it right the first time, all leading to lower costs and a better customer experience, meeting the high expectations of the market today. A DevOps revolution is taking place across all industries. We see, for example, in the financial services industry, in the telecom industry, healthcare, manufacturing, and retail, everywhere really. While the value of DevOps is widely understood, few companies are satisfied with the results. Despite its power, DevOps can be difficult to implement for a variety of reasons. And today we're going to focus on one of those reasons. While the vast majority of companies surveyed by Harvard Business Review say that they're currently adopting DevOps practices, only 10% of those companies say that they're happy with their results in the DevOps implementation. So as I said, let's look at one of those reasons. Now, this is very important because it used to be when a company would join the S&P 500, when a company would be listed on the S&P, you can expect on average that their life expectancy on the S&P would be 75 years. However, more recently, this number has declined to 15 years on the S&P. So the best companies have had to reinvent themselves all the time. It's keeping executives on their toes. And what we've seen over the last few years, what with COVID and political turmoil and inflation and supply chain disruptions, everybody is working very hard to stay on top of their game. The new disruptors are all embracing DevOps. Here are some of the companies that have embraced DevOps very publicly and wholeheartedly. Some of them are our customers. And those who lag behind risk falling behind. However, and there's a big but, there's a lurking danger here. A lot of companies are investing a lot of time and effort in the DevOps flow of planning and developing software and building the software and monitoring and this virtuous loop, this cycle, but there's a roadblock along the way that often doesn't get noticed. And that's the the test data roadblock. Many times, companies are using traditional practices for supplying test data to QA and dev teams. And the way it normally works is that testers submit a request for test data where they list exactly which test data they need. And then DevOps teams will work on finding that data and preparing it and cleaning it up and getting it ready, getting it compliant with privacy regulations. But many times that test data arrives to the testing teams incomplete. And while they're waiting for the test data to arrive, their productivity is impacted and their efficiency is low. So why is it so hard to provision test data? Well, without the right tools in place, the process is a lengthy, complex process where you have to take data from production sources, make a copy, you have to profile the data and map out the relationships. You have to prepare a staging environment, and you have to transfer the data to that environment. You need to scrub the data and format the data and mask the data, and you need to prepare it in the right format. And you might need to do other transformations and then deliver it to the various dev and QA environments. All of this can take a long time, especially when there are different data sources involved. And these data sources may have, and often do have, different technologies. They're in different environments. So you need to bring data from production to a QA environment, and there's a lot of complexity involved. And along the way, you have to make sure that the data is robust, it's compliant, it's specifically what QA teams need. You have to make sure that it's sufficient for coverage. There's a lot that's involved. And if one is not doing it correctly, then poor TDM results in slow software delivery cycles, partial test coverage, and product managers don't have full confidence in the products that they're building. In addition, the DevOps teams that are involved in preparing this data have to do a lot of manual processes that are not very fun to do, frankly. And this leads to a poor developer experience, and the QA teams also are not happy that they're not fully engaged and productive. So let's look at some of the challenges that we see in the market today. One of the biggest challenges we see is integration and connectivity with different data sources. So some organizations have legacy data sources such as mainframes and SAP, and they may be taking on some new data sources, whether they're in the cloud or on-prem. They may be NoSQL databases, and getting the data from these sources to testing environments can be a major headache. In addition, there's a different masking. Masking is required because of privacy regulation. Everybody wants to be compliant, but different vendors require different masking techniques and different masking tools, and this can be quite complex. In addition, it's very important to provide testers with subsetting, and you don't want to provide all data to testers. You want to provide just the data that they need. And there are other operational functionalities and needs that testers have, such as having a clean testing environment where other testers are not overriding their work. And you need the ability to have version control for test data in order so that they can be productive. And if they spend a lot of time, for example, preparing a data set, they have to be able to save that data set and come back to it later in case the data gets corrupted. Another requirement that we're seeing in the market is for synthetic data generation. We're going to talk more about that later in great detail, so we're not going to talk about it now. And lastly, as I mentioned, with DevOps, the world is looking for automation and integration into CI/CD pipelines. And the question is, where does test data management come into play here? So let's define test data management for a moment. Over here, you have Gartner's definition. But to put it more simply, it's the process of enabling DevOps teams to create, anonymize, and provision data for software testing. Gartner says that in some cases, synthetic data generation may be appropriate, and we're going to talk about that. We're going to discuss today how a DevOps approach to a traditionally manual process can accelerate software delivery and improve quality. So why is test data management important? We want to find defects in the software as early as possible, because the longer it takes for the defects to reveal themselves, the more it costs to fix. Bugs are the #1 cost driver when developing software. So more and better testing results in a lower cost of developing software. In the chart in front of you, you can see with the orange bar, with the orange line, where defects are found in what stage of the process of the software delivery lifecycle. So you can see that as the software SDLC cycle progresses from coding to unit test to functional test to system test and to release into production, the cost of fixing bugs once they're detected rises exponentially. So how much does it actually cost? So there are various estimates available, but one estimate that I've seen is that the cost to fix a bug when you find the bug in the gathering requirement stage is $100 per bug. When you find a bug in the QA testing phase, it can cost on average $1,500. And when you find a bug in production with all the coding and the refactoring and the subsequent regression testing, all the testing that's required, the cost goes up to $10,000 per bug. And that's in the best case scenario when the bug didn't have a major real world impact. In worst case scenarios, bugs can lead to total shutdowns of service. Like we've seen, for example, when all of a sudden Gmail goes offline or WhatsApp goes offline, the whole world of social media, other social media platforms all of a sudden stop working. It causes a major commotion. And outside of the digital sphere, bugs can appear also, rockets can explode after takeoff. Automobile manufacturers need to recall millions of vehicles. Financial institutions that are using algorithmic trading, bugs can creep in there and cause major losses. So the need to find bugs earlier in the testing cycle is very acute. And this is what's called shift-left testing. Shift-left testing is all about testing earlier and better in the software delivery lifecycle. So one of the benefits of shift-left testing is a major savings and the reduction of cost in hardware and software. So this is because without a TDM tool, many companies are making copies of production databases scattered throughout the enterprise. And this causes a lot of redundant hardware and software. And there's a lot of cost and headache in managing this. Secondly, a lot of time is spent by testers looking for, and creating the test data they need. Having the right data available on demand to test earlier increases the velocity and efficiency of testing and accelerates software delivery and increases the velocity of software developments. Lastly, it's not just the speed of the software development, but it's also the quality of the software. As we mentioned before, finding bugs earlier in the software. We do this by maximizing test coverage with robust data sets, test data sets. And by testing application software thoroughly, and we cover all the edge cases, and we have large data sets for performance testing, then product managers have greater confidence in the software quality and a lot of cost savings in terms of fixing those bugs. Let's look at where test data management is in the market today. So this is Gartner's research called the Hype Cycle for Agile and DevOps. This is their most recent edition. Here, Gartner places test data management almost at the very top of the DevOps Agile hype cycle. This means that TDM is top of mind for many companies that have not yet implemented tooling. How many companies are there like that, you ask? So Gartner estimates that TDM tooling has only penetrated 20 to 50% of the target audience, and we are still 2 to 5 years away from TDM becoming mainstream. So who's involved in creating test data? Traditionally, application developers and DBAs we're working together to create test data. But with the new privacy regulations that have come in recent years, security and data governance teams are being brought in. Legal teams want to make sure that everything is being done correctly. And there's a lot of work being done in identifying sensitive data, otherwise known as PII, within the organization, tracing the lineage, and cataloging data relationships. So what to do? How do we solve this test data management challenge? Let's take a look at Gartner's recommendations. First of all, Gartner says that a strategic approach should be taken to test data management. It shouldn't be a one and done affair where you make one investment and then forget about it for the next 10 years. But rather, just as software development is an evolution, test data management should also be an evolution. Secondly, you should involve more stakeholders. You should identify consumption patterns and needs of test data throughout the organization and get more stakeholders involved early on. Make sure to document existing TDM practices so that new tools can be benchmarked against a baseline and the benefits of the TDM tooling can be quantified. Additionally, you want to avoid duplication of efforts and unnecessary expenditures by coordinating with other teams. Something that we see very often here at K2View is we see enterprises that have test data management tools implemented in silos. So different business units are implementing different TDM solutions. And this is not considered best practice by Gartner. Additionally, when evaluating data masking tooling, you should consider support for the different technology types and vendors, its data discovery capabilities, the masking types and functionalities and algorithms that's built in, and make sure that the tool maintains referential consistency for key fields across multiple sources. Now, where relevant, and again, we're going to talk about this in greater detail, consider synthesizing data, consider synthetic data where appropriate. Or, for example, if synthetic data is if production data is not available, or the risk of re-identification is high. Also, you want to communicate the implications of the poor TDM practices we talked about to stakeholders. Development and testing efforts can be slowed down by poor practices and become a bottleneck to productivity. Additionally, they may conceal the many benefits and capabilities of TDM beyond compliance. And you want to optimize TDM and orchestrate investments by making them an ongoing rather than a one-time affair. So relationships between data exist not just in databases, but also in source code. As a result, software engineering leaders should not implement TDM at once, as I said. Instead, you should build what Gartner calls a platform team, and what we call here at K2View a TDM Center of Excellence. What does that look like? So according to Gartner's study shown here, 82% of respondents are using platform teams of some type. And the purpose of these teams is to implement specific test data management technologies and practices to accelerate innovation and remove roadblocks from development and testing teams. So we recommend a centralized DevOps TDM team, which provides a centralized test data service for all business units in the organization, so that it obviates the redundancy of production databases and test data stores sprinkled throughout the enterprise. And this way, you have best-of-class test data management services throughout the organization. So let's look at the different approaches to test data management. The first approach is the manual production copy. So this is, as I mentioned, making copies of production databases and spreading them all over into different environments where needed. So a testing team is asking for data. So what the approach is just to copy production databases and provision the test data from there. Of course, after masking them, as we described before, and we'll talk about more in a moment. The second approach to TDM is a test data warehouse approach. Instead of the first approach, which is to copy production databases all over the place, in this approach, you have a centralized test data warehouse, only one, that has all the test data that you need. And that test data warehouse syncs with the production sources so that there's no duplication of efforts. And in this test data warehouse, there's various functionality, which we'll talk about. The third approach to TDM is not to send data from a test data warehouse to QA and dev environments, but rather to virtualize data. We're going to talk about that in a moment. The fourth approach is to generate synthetic data. So instead of using production data, you just create synthetic data via various methods, which we'll discuss. And lastly, the fifth approach to TDM is the business entity approach. So let's look at it one by one. So the first approach we mentioned before is without the right tool in place, preparing and masking data, test data, is a very long, complex process. And we've seen actually some organizations are still not masking production data. They're taking production data sources and giving it to testing teams and development teams with the original data in place. And this is not an ideal approach. It's not compliant with privacy regulation. And this is why these companies are looking to implement a TDM solution. The second approach is the test data warehouse approach. It was pioneered by ETL vendors such as IBM Optim and CA, now CA Broadcom, Informatica. It started in 2008, where these ETL vendors took an ETL approach to TDM, where they created a centralized data store. And the advantage here, as I mentioned, is that all the data is in one place. And they built a layer of features and functionality on top of this test data store that QA teams need. For example, version control. For example, subsetting, which is very important. Instead of copying terabytes of data into a staging environment, a subset of data, which is all that's needed in most of the time, which has a much smaller footprint and has exactly the characteristics that's needed, can be provisioned to the QA team. So the common denominator between these vendors is that they all have a lot of experience in the market. They can provide end-to-end TDM for most data sources that are in vendors in the market. They can provide various services such as subsetting and synthetic data generation. But depending on the vendor, each of these major functions are packaged in a separate module. So sometimes it has a separate UI, sometimes not. But since each of these modules may be priced separately, you may want to decide in advance which modules you want to buy. So data virtualization. With data virtualization vendors, create a persistent copy of data in a highly compressed repository. From that centralized persistent copy of data, very similar to what we saw in the previous examples of the test data warehouse. From there, here's where it changes. From the test data repository, virtual copies can quickly be made to lower environments such as testing environments. Now, one of the advantages is that these virtual copies can be spun up very quickly, but a disadvantage is that due to the inherent nature of this virtualization technology, it's only available for a limited number of databases, and adding new data sources is a big endeavor for data virtualization vendors. Now, data virtualization vendors typically preach that subsetting is not required because they say that they're presenting all data, so they don't need just a subset of data. But what we hear from our customers is that many times they don't want all data. QA teams often do not know, individual testers don't necessarily know where the data that they need resides. They don't necessarily know the network architecture and which database has which data. And they may not be savvy in SQL. And therefore, subsetting data is not something that they advocate. Also, due to the fact that the data is being sent from the central data repository, presented as a view to the testing environments, so since the data is virtualized, there is no built-in data transformation by nature. It's not a data transformation. It doesn't have data transformation capabilities built in, which, for example, in approach number 2, ETL vendors oftentimes have data transformation capabilities. Again, it may be a separate module, but they do have those capabilities. And so who is data virtualization good for as it relates to test data management? So companies that have a few popular vendors for databases, this could be a very good solution for them. Another approach to test data management is synthetic data generation. So production databases are usually very large, and the data is sensitive data. Because there's sensitive data in these databases, so there's access control and security controls, and not everyone has, even the DBAs don't have access to all data throughout the organization, perhaps. So getting the data that's required from the production databases to the testing environments can be a challenge. Now, if you create synthetic data generation, if you create test data synthetically, and if you assume that this data doesn't have any characteristics of the real data, so this data is compliant by definition, and that's one of the advantages of synthetic data generation, that if done correctly, it could remove the headache of masking data or being concerned about data privacy. Another advantage that some people cite is that production data inherently contains real-world biases. And if you want to create a data set that doesn't have bias, then, or for example, to represent something that doesn't currently exist in production, so synthetic data solves that problem. So bottom line, synthetic data can be used instead of production data, or most often it's used to supplement production data where real data falls short or is unavailable or inaccessible due to privacy regulations in specific geographic areas. So what are the different synthetic data generation methods? So for test data management, there are 2 primary methods. The first method is the rule-based logic method. With this method, synthetic data is generated through predefined rules and metadata definitions to create new data. The advantage is that with these rules, you don't need to base it on source data. So it involves specifying logical conditions, constraints, and relationships, for example, between parent-child relationships. And you have the opportunity to define rules. So what are these rules? So for example, if you look at your production database and you have millions of customers with different dates of birth. So when you want to create synthetic data to supplement or replace production data, you can define rules for what the spread of ages, the date of birth, should be in the synthetic data set. So for example, you can define a rule that the age or the date of birth will be plus or minus X years or months or days from the original data. So in summary, rule-based logic can be used to correct bias in the production data. So for example, if you want a 50-50 split between men and women. And it's very appropriate for data that's not available in production. So for example, if you're a telecom carrier and you want to test the carrier's application support for Apple's iPhone 15, and if the Apple iPhone 15 is not yet in the market, so you don't have an iPhone 15 in the data in production, with the synthetic data generation through rule-based logic, you can create your own data and say, I want an iPhone 15 and I want an iPhone 16, and you can create made-up model numbers as you wish. The disadvantage of this approach is that it requires deep understanding of the underlying production data and relationships, And to create all of these rules and relationships is very effort intensive. The second approach is through machine learning, creating data, synthetic data through machine learning. So machine learning uses algorithms to learn patterns and relationships in the original data and generate new data based on those patterns. It involves training a machine learning model on the original data set and using it to generate new data that follows the same patterns and relationships as the original data. So the advantages of using machine learning is that this model, this machine learning AI, looks at the production data and creates a realistic looking data set with relatively low effort. And if done correctly, it can result in realistic, rich, and fully compliant data. The disadvantage is that, first of all, this technology is still in its infancy, and we still have years to go until it can be, like a ChatGPT type experience where you just, input something, a prompt, press enter, and get the result that you want. Creating generating synthetic data this way is still in its infancy, as I said. And in order for it to work, it requires access to the production data. And as I said before, you can't use it to test new functionality because the data will not exist in production, and it doesn't cover negative testing, for example. And another thing that you have to be on watch out for is for the business logic inherent in the data. So if the machine learning algorithm creates data that doesn't make sense of business logic, for example, the total invoice amount field in one table needs to reflect the invoice line items in another table. So if you create business rules using the previous method and you set it up correctly, it's going to be fine. But if the machine learning just has its own way, it may result in results that don't make any sense. And just one last thing. So which is the better approach, the first approach or the second approach? So here at K2View, we think that a hybrid approach is actually best. If you can get the best of both worlds, then that's the way to go. So the fifth approach to test data management is the business entity approach. And here at K2View, this is the approach that we take. And we think about test data by organizing the data by business entities. A business entity can be a customer, an account, a mortgage, or anything that is central to the business. Let's use customer as a business entity. So think about a company that has customers, consumers, millions of consumers, and the information for these consumers are spread out through various databases across the organization. And what we do with the business entity approach is we collect and sync this data and model all of this data into a secure micro database. A micro database, or rather a business entity, is a mini database that contains all of the information that exists of the customer and places it into the test data warehouse. And each of these micro databases are compressed to up to 80% of its size, and it maintains the relationships between the data inside each of the micro databases. And then the data is accessible to the test environments through a tester portal, which is a web-based portal that testers have to access the data through a user interface that is easy to use. And without knowing where the data actually resides or what the architecture of the system is, they can simply click which data they want and press go, and the data is provisioned to them. Now, DevOps teams can connect to this test data warehouse through APIs and pull the data as part of the integrated CI/CD pipeline. Each of these micro databases are secured with its own 256-bit encryption key, so that even if somehow there would be a data breach and somebody would be able to crack into the test data warehouse, which is very unlikely, they would still be presented with millions of micro databases and business entities, each one secured with its 256-bit encryption key, which is almost impossible to hack. So what are the advantages of provisioning test data by business entities? So we created an acronym that's simple. So the way we think about data is not about tables, rows, and columns. We think about data in terms of business entities, and this provides the following benefits. First of all, you can subset test data through business entities easily and quickly. It frees up the DevOps and engineering teams from spending a lot of time manually preparing test data. It reduces the time to prepare test data dramatically and enables testers to test right away without delays waiting for data sets, thereby accelerating software delivery cycles. It also, I stands for isolating the complexities of the underlying source systems from testers, where making it simple and intuitive for testers to perform any operations on the test data. M stands for masking dynamically, in flight, with no coding and no staging environments. P is about performing complex data transformations without requiring hard-to-maintain batch ETL processes. This removes the need to pay for additional tools and spend the time manually to perform these processes, resulting in a lower total cost of ownership. L stands for loading the fresh data from production, and it provides the flexibility to keep the test data store as fresh as needed. So when testers are pulling data, they can decide whether they want the freshest version in production or whatever the latest version in the test data warehouse is. There's no need to duplicate databases all over the organization, reducing cost, complexity, maintenance, and risk. And E is about ensuring relational consistency of the test data. With a business entity approach, by design, the relationships are preserved even after masking, so that the data for every business entity is complete from all underlying source systems. This allows testers to cover all required test scenarios and maximize test coverage. No more looking for test data or not having enough test data. The business impact of this is a higher quality end user experience, faster software delivery, enhanced tester and developer productivity, and full compliance with data privacy regulations. The K2View test data management solution uses PI discovery to analyze the data in the various data sources, to map out the relationships, to build a data catalog for any database, any version, anywhere and any time. The K2TDM extracts the data from the data sources, anonymizes the data in flight, transforms the data as needed, and places the data in the test data store. From the test data store, the data can be a subset or synthesized or versioned or rolled back, all using the self-service portal by DevOps or QA teams. And DevOps engineers can use APIs to trigger the very same functions. All of the functionality available in the self-service portal is also available through APIs. Now, the DevOps teams can use the K2 platform to define masking rules, choose between hundreds of different masking algorithms, and define the synthetic data, as we discussed before, to define sync policies and role-based access control, and whatever data transformations are needed, for example, aging. All of this as they provision data from the self-service, from the TDM warehouse into the various UAT production, QA and dev environments. So a few words about K2View. K2View is the only test data management solution that can integrate with any data source. For test data management, we serve enterprise customers in the financial industry, such as American Express, Sun Life Financial. In telecom, we serve companies such as Vodafone, Verizon, and Rogers. In the healthcare industry, companies such as IQVIA and more. Last year, we made our debut into Gartner's Magic Quadrant for data integration, which includes data masking. For your information, there is no Gartner Magic Quadrant for test data management, but there are plenty of reviews of K2View on the Gartner Peer Insights website. So feel free to see what our customers are saying about us. And now we're up to the Q&A session, Q&A part of the session. If you'll just give me a few moments to review the questions that have come in, and I'll answer whatever we have time for. So we have a question about as follows. If we keep generating synthetic data for testing needs, how about the storage cost for the synthetic data? So the synthetic data can be generated once, and according to the business entity approach that I described before, and the synthetic data resides one time in a test data repository. And from there, you can subset the synthetic data into any testing environment. So thank you for the question. And the answer is that there is no additional cost of generating synthetic data. In other words, synthetic data generation is a built-in capability in the K2View platform. It's not a separate module, and it does not it doesn't grow the cost of the storage. Another question is, does K2View support dynamic data masking? The answer is yes. Feel free to reach out to us offline, and we'll be happy to tell you more about that. Another question, you said that K2View can connect to any data source. How do you do that? So at K2View, we use different methods to connect to different data sources, from legacy mainframes to NoSQL databases and relational databases of every kind. We have different methods for doing so. The most common method we use is through JDBC drivers, otherwise through APIs or other methods that we employ. Another question, okay, running out of time, we'll make this the last question. Somebody's asking, I heard that Informatica is not selling TDM anymore. Is that true? So, what I've seen is that Informatica announced end-of-life support for their on-prem solution. To my knowledge, they're sunsetting their on-prem solution. They've created a new cloud solution that I believe that they're still working on. It's a new, to my understanding, it's a new deployment, that there is no migration from the there's no easy migration from the on-prem Informatica TDM to the cloud. So that requires a close look. That's what I've heard about it. But of course, do your own due diligence. We're out of time for today. Thanks for joining us, and see you next time at the next K2View webinar. Thank you.